Welcome back to the Algebra 2 series. Today we are continuing through our quadratic functions section, and uh, in this example we have two separate functions, f of x and g of x, representing the y values of each of their respected functions, and here they are down in the bottom. What we're trying to do is work several things here at once. The first one, solving for the f of x equaling g of x, or in other words, solving where the two y values are equal. And that should give us some values of x as well. The second thing that we're going to do is graph both functions on the same axes. So that should give us a picture of what happens in part A. So the first thing I'm going to do with part A is just simply take f of x and set it equal to g of x. In this case, I end up with negative x squared plus 4 equal 2x squared minus 5x plus 6. And what we're doing is we're saying, why don't we find the x values in these functions where the y values are the same? So notice that f of x and g of x are equal, so we're going to test this out by setting this equal to 0, getting 2x squared on the right-hand side, minus 5x, and then subtracting the 4 gives us plus 2. And hopefully it's factorable. Sometimes it is, sometimes it isn't. In this case, I think it's going to be. And then we'll put two minuses there. That looks pretty good. So x is equal to a half, or 2. Those are the two places, and if you think about what this is telling us, this tells us that at x is a half and at x equals 2, the y values are both the same. So that helps us to understand a little bit more about the graphs. And in just a second here, when we graph it, we should see that kind of come about as well. Let's move this up a bit, move this up a bit as well, and then graph these on the Cartesian plane. So it says graph by any method. We'll start with the f of x function. I'm going to put that one in green. And it says negative x squared and then plus 4. So flip it over the x-axis and then move it up 4 units. And I'm not going to show the intermediate steps here. I'm just going to graph the final graph, which looks like this. Vertex is at 0, 4. And then it goes through at 2, and then I believe we go here at 1, 3, excuse me, negative 1, 3, and 1, 3. So here are our, oh, I missed. I'm going to do that again. That was horrible. Let me try this again. I can't quite see this on the thing, but here we go, and then I'll just kind of cheat here a little bit. All right. Okay, so there's our first graph. This is F. And then I'll use the other color to graph g of x. But now notice that in red here, g of x is not in transformational form, but it could be factored into x minus 3 times x minus 2. And when it says graph by any method, that means any method. Now here we can see two x-intercepts, one at x is 2 and one at x is 3, and this opens up. The third point that might be informative for us is the point 0, 6, the y-intercept. And notice you can find that right here, just like we did yesterday. And therefore, just connect the dots. This gives us a picture something like this. And I know that there is a vertex down in here somewhere. I have not calculated it, but I know it's down in there somewhere. It doesn't appear to be really influential for our graph. Then when I got that done, and of course there's a 6 up here, we notice that at 1/2 and at 2 is where these two graphs intersect. And here we have one point right there, and then the other one looks like it's right up here somewhere, and that should be at the ordered pair 1/2 comma something. We're not sure where that is, but this one of course is 2, 0. That's the first one. All right, so part A was to solve the two equations. The second part, part B, was to graph them. And part C is to calculate where the intersection points are. So there's obviously one at 2, 0. And then let's fill in this other one by substituting the number 1/2 into either function. So I'm going to go put it into f of x. It seems easier to me. So that would be negative 1/2 squared plus 4, or negative 1/4 plus 4, which is 15/4. So I'll put that right up in there as my second ordered pair, 1/2 15/4. And that's all we need to have for those guys. So we're doing kind of three things in this one. First, we're working on some sort of equation or inequality in this case, and then we're graphing them. Oops, excuse me, that's 4. And then after we graph them, we find their intersection points. All right, so that's the first part. And I want to go over one more thing, and that is to determine the number of x-intercepts that each parabola will have and determine if there's a max or a min. Well, let's start with the number of x-intercepts. We saw this actually in an earlier chapter where to find x-intercepts, we solve 2x squared plus 3 equals 0 and determine how many answers it has. So that means we're looking for an inspection of the discriminant. And if the discriminant is equal to 0, then we had one answer. So that would make one x-intercept. And then the second situation is if b squared minus 4ac is less than 0, and that would be no real solution, so no x-intercepts. And finally, part 3 is to say that b squared minus 4ac is greater than 0, and that would mean 2 x-intercepts. So that's how we're going to test that. And in this problem, there is no b term, so a equals 2, b equals 0, c equals 3. b squared minus 4ac is equal to 0 minus 4 times 2 times 3, or a negative number. So there are no x-intercepts. And this makes logical sense. So no x-intercepts. And the second half of that is to find out if it has a max or a min. Well, you could pretty much visualize what this one's going to look like. We know that it opens upward because the 2 is positive, and it's because it's going to open upward, there's going to be a minimum in there. So here's how it would look. We'd have 3 units high, and it would go upward like this. So that's going to be our graph, and we would say there is a minimum, a local minimum or a minimum when x equals 0. That's the minimum. So let's start with a couple of things. We found that there were no x-intercepts. There was a minimum when x is 0. And the last thing we put down is that the minimum, this is a little tricky, the minimum value is the number 3. It's located right up here at the vertex value. That's the y value. And that's the only time we really talk about the y value is when we want the minimum or maximum value. So look at that, look for that key word, value. Let's take a look back at if we've answered the question here. Determine the number of x-intercepts that each parabola will have. And so we found there were no x-intercepts here. Determine if there is a max or a min. We determined that there is a minimum, and then we found what that minimum was. Well, what happens here now when this is a lot more complicated? First of all, you'll notice that it's in the wrong order, so that's a tricky little problem. Negative 4x squared plus 3x plus 4 changes things a little bit and makes that leading coefficient negative. Let's start with the first part. I'm going to label this part A. B squared minus 4ac is equal to 3 squared minus 4 times negative 4 times the final 4. Wow, a lot of 4's here. We end up with 9 plus 64. So there, that is a positive answer, 73. And it doesn't matter what the number is. We just want to know if it's positive or negative. In this case, it's positive. So we'll say that there are 2 x-intercepts. Next, we want to find out if there's a max or a min. Well, because this leading coefficient is negative, we know the graph is going to do this. It's going to open down. So there will be a maximum when x equals, well, we have to figure out what that's going to be. But we know that that's going to be the x value of the vertex, which is negative b over 2a. So the negative, the b value being 3, twice the a value, negative 4. So this should give us a number of 3/8. So when x is 3/8, I'll write that in there. And that gives us the first part there. And then the last thing we have to do is calculate the value of the maximum. Remember, the value of the maximum is the y value. So we're actually going to calculate g of 3/8. I believe I had a little trick for that in class. When you plug that number in, -4 3/8 squared, and continuing here, plus 3 times 3/8 plus 4. And the little trick was that you just have to figure out what that first term is. So that's going to be 9, and the 4 cancels the 64, making a 16, and that's negative, plus 9/8 plus 4. And the answer is, if you recall from class, I said it's going to be this fraction with that sign. So 9/16 plus 4, or 9/16 plus 64/16. That gives me 73/16. And isn't it intriguing that this 73 shows up one more time? It is the y value of the maximum. So the maximum value of the function is 73/16. That's a little bit tricky, but it relates to the vertex. It relates to how we look at parabolas. And in this case, it shows us some information about our function. It shows that it has two x-intercepts. It shows us that it has a maximum when x is 3/8. And it actually tells us what the maximum value of the function is. Hope that takes care of business for our assignment. Good luck tonight.